everybody. Hello from my favorite artist electronist, Mr. Q12.
What you are seeing here, this is the board, FT232LL. So this is the name of the board here. Pretty much I plug it into this breadboard. I have this LED, you can barely see it probably, and it's having a resistor there on its negative leg, and this bent leg here is the positive pin of the LED.
And this is the connection that I made here on this breadboard. Here on top, the program info Visual Studio 2010 projects, and here I have a new folder called serial, and inside I have this C# to FT232RL direct communication, and it is this file that you are seeing here. Is not that much of a code, so I had to ask ChatGPT a couple of questions how to make the simplest possible way of communicating, of transmitting data to this TX pin of this specific board, and he managed to give me a very simple and to the point program. This is the code that he generated. Then I transformed that basic code into a function. I could do it myself, but it was taking me a bit more time to concentrate and to actually manage it. But he gave me the answer in a couple of seconds. I copy and paste it and make some minimal correction on it, and it worked. And it actually blinked my LED there. Program is using two functions in it. So this is the function for the button. As you can see, when you are clicking this button, this is the function for it, and it's having inside is counting to 10 or to infinite, whatever you like. And I have two functions: transmit X pin when it's on, and I have a milliseconds argument there. I'm passing this 200 to both of them, and a transmit X pin off function. And this is the transmit TX off function. It's very, very simplistic. Actually, I made it this simple because ChatGPT was unnecessarily complicated. Or actually, the pin is off. The LED, this LED is off. That's what I was actually looking for. So when that LED is on and when that LED is off. But I keep it as transmit X off and on because I'm toggling that pin particularly. And this is the code for when that pin is on. These are the settings. I'm telling C# to use COM5. How can you find what port name you have in use? You go here, control panel, I believe. Device manager, this one. All right, and you go to ports here, connection that is coming from a wire, and it's actually this gray wire that you are seeing it here, and this is connected to my PC. And this is how you check what COM number you have. In my case, it's COM5. So you have to change this. Baud rate doesn't matter what you use. I'm not completely sure what are the limits for this board. So I used this default number that I've seen it everywhere on the internet. So I'm playing safe in a sense. And very shortly, what this code is doing, actually, let me play it first.
As you can see, is actually blinking two LEDs in parallel because that red LED that you are seeing on the board is connected to transmittix with the same pins as I connected this outside LED. So this and that are in parallel, but this is an external LED or a component that I can play with, while that one is a component that is on board of this device, of this board, and is confirming that I'm doing the right thing. Actually, because of that little LED, I could figure out how I can connect this external LED, because before I was connecting it to negative and to transmittix, and that didn't work. And that's it. So let me play it again. Is blipping 200 milliseconds, and if I'm changing here to 20 milliseconds here, let's play it, and when I'm pressing the button, it's blipping a little bit more faster. And if I'm sending 2 milliseconds, let's press blip, 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 blip. It should have been a bit more faster than that. I'm not even sure if the camera will catch the blipping because it's very short. So let me on the back, and here is 1 second. Okay, so let's see, this will be longer. And I believe this is not actually correct timing what I'm having here, but it's good enough. This is not by any means 1 second there. It's a bit longer than that. This is the program. Let me show you, explain you the code, what is doing inside this function when it's keeping that LED on, because this is a bit of a trick this code is doing. I was partially aware of it. I'm not working with this kind of stuff every day. Actually, this is my first time when I'm using this setup, what you are seeing here on this board. So pretty much here and here, these two lines is dealing with the timing. It's converting this milliseconds into actual milliseconds. This line is the most smart line from the entire code, and is doing all the job of keeping that LED on. Serial port write, new byte is an array, byte array, is sending a dummy byte of 0x, and that's it. It's that simple. And if I'm collapsing these two functions, you can see how minimalistic this functional testing program is. I'm quite happy that I managed to make it work. Probably there are ways more simpler than the way I did it here. This is probably bit banging what I'm doing here. Most probably it is bit banging this particular board to command external components like this LED in this case. So this is the limitation of this board if you want to command its outputs, and it's having only one single output. That's the problem. Also having an input pin that you can use it. So R is reading the data, so this is the input pin, and this TX is the transmitting pin and is the output, and is having only this output and this input. In principle, what this board is meant to do is to transmit a series of data on this line. And here is a microcontroller usually that is receiving that data, those bytes, and this microcontroller is converting those bytes, is understanding those bytes, and after that is sending on in-out pins, however many is having, and lighting up a bunch of LEDs or LCDs or whatever devices you are hooking up onto these pins. So this is the normal functionality of this board. This is what is meant to do and how to use it. But you can use it in the stupid mode, like I did it here, pretty much faking sending the data. So this is what this line is doing. This is what this dummy byte is actually the meaning of it. This kind of data you should actually send to a device, and that device should interpret this data, should understand it, and actually respond back to my program here in my C# and send a byte of acknowledgement or something like that, and then my program will calculate something and will say, yes, I received your receiving data, here more data, and continue do your job. And this is a back and forward communication, and making sure your device is listening to your C# application and to your computer transmission bytes that you're sending. So this is the typical communication way of doing things. I'm not an expert, but I know some stuff. Again, I'm not working with this stuff every day. I'm the average Joe, just playing around. Okay, that's it for this about how to drive it, and I hope you like it. Also leave a like and leave a thanks, and thank you for watching from your favorite artist electronist, Mr. Q12. So let's blink it again. That's it. Bye bye.